Shall we get started, Rahul?
Yes, sir.
Okay. Let me share my screen here. Okay. So last week, I think we were looking at integrating the logs of AWS RDS with New Relic. Today, we look at a monitoring ELB in New Relic. It is almost a similar process, almost for any kind of AWS service, but we'll look a little bit deep into this one, okay? So by now, I'm sure you all have an idea of elastic load balancing. It's more about load balancing. For any instance, if application fails, then it would be unavailable to the users. Generally, an application fails when there are too many requests or if the server is getting overloaded, or if some security attacks bring it down, or maybe some internal issues with the server. That's when a server could go down or an application could go down. Sudden spike in the traffic, your application may not be able to handle additional load. So imagine an e-commerce website where suddenly on a particular festival, maybe at Christmas, the amount of requests have increased exponentially. And that is where an application or server may not be able to handle that many requests, and that's where it may end up becoming unavailable. So how does the load balancing work? Elastic load balancing automatically distributes incoming application traffic. I'm sure you already have an idea about these. These days, we are getting lots of requests, not only from the browsers or the desktops or the laptops, but also the mobile phones and maybe tablets and other kinds of devices. There are lots of requests coming into the servers, and such traffic from multiple targets can be equally distributed. That is what the load balancer does. It can handle the varying load of your application traffic in a single availability zone or across multiple availability zones. So in other words, going back to zone is nothing but a group of data centers. And a data center is again a group of clusters. Clusters is nothing but a group of racks, and a rack is a group of servers. So the AWS load balancing is balances the load across multiple zones and data centers is what it is. There are different kinds of load balancers: the application load balancers, network load balancers, gateway load balancers, and classic load balancers. Application load balancers, flexible feature set for your web applications running the HTTP or the HTTPS protocols. So in other words, more precisely, application load balancers are the external load balancers. These are the load balancers where the traffic from the internet is being first routed or directed to this load balancer, and this is internally equally distributing the traffic. Network load balancer is best suited for load balancing TCP, UDP, and TLS traffic where extreme performance is required. In other words, network load balancers are mostly internal load balancers. The load balancers which are generally used between an internal web server and multiple databases is generally a network load balancer. Gateway, it gives you one gateway for distributing traffic across multiple virtual appliances. This is again, from what I recall, it comes up where a company is specifically migrating to cloud from their on-premises model to cloud model. That's where the gateway load balancers come. Classic load balancers are the traditional load balancers used by EC2, used for applications that were built in the EC2 classic environment. In other words, by default, most of the times we are using the EC2 classic environment. Load balancers is what it is. So how does it work?
What is that gateway load balancer?
Gateway, from what I recall, it is used from when a specific company wants to migrate onto the cloud. They're setting up the specific VPNs and VPCs. That's where the gateway load balancer is specifically used.
It is for on-premises.
On-premise to cloud.
Okay.
An explicit traffic and things like that. Okay. So the load balancing automatically distributes incoming application traffic across multiple targets. Okay, I think we looked at this. Components. So at a slightly technical level, this is just to get an idea. The components of load balancing, there are cross-zone load balancings. A load balancer will also have a group of rules. And let me just move my screen here. Okay. And it will also have a group of nodes. Nodes is where it is redirecting a specific request to. Load balancers listen to this traffic. So in other words, they're referred as the listeners. And internet facing, those are generally the external load balancers. Internal is again, as I said, within the network. And target groups and health checks. Generally, I don't really recall what is a target group. Or a target group is, I think, is the consumers. Consumers is nothing but the where it is routing the traffic to. That will become the target, and that's where a particular request is getting processed. Health check is on generally the load balancers. Before a request is getting routed, the health check is done on load balancer to make sure it is up and running. We can also have multiple load balancers. So if one of the load balancer is down, the request is rerouted to another load balancer. Slightly at a high level, these are the technical components. And here is an example of cross-zone load balancing. If cross-zone load balancing is disabled, notice here what we have is on the left-hand side, we have zone 1, and on the right-hand side, we have zone 2. So 20 plus 20 is 40. If you count all these things, I think they are about 41. So 40 on the left-hand side, 40 on the right-hand side. What is happening is, if we disable the cross-zone load balancing, 40 requests are getting routed to the left-hand side zone, and the 40 requests are getting routed to the right-hand zone. And if the cross-zone load balancing is enabled, then notice the change in the number of the requests. So this, the orange, the thick orange squares are the ones which are the nodes where the request is getting processed. So now instead of 5 or 20, so if you disable the cross-zone load balancing, unequal number of requests are getting distributed. And in other words, the left-hand side zone here is getting overloaded than the right-hand side, or overconsumed is what we can also think. Whereas if you enable the cross-zone load balancing, they're equally getting distributed. No node is getting overconsumed, and they're all equally getting the requests, and as a result of that, the network is also used in a balanced way. That is one of the advantages. So again, load balancer, it has a listener, it has a group of rules, and the listener again internally has targets, and the target group, I think, is one which is performing the health check. Target is the node where the request is getting processed. Is a slightly high level look. Advantages, high performing applications. If you're generally looking into e-commerce applications, maybe a stock trading application and things like that, these are very highly applications where they really get hundreds and thousands of requests per minute. So those are examples of high performing applications. So the load balancing, again, we can auto configure them to scale up, scale down. They're automatically, in other words, high availability is provided with them. And business continuity. So it helps in business continuity, removing the stage of failure. So in other words, this is how we are handling the failure. And they are secure, robust monitoring and noting. So in other words, we'll try to get a feel of how to integrate with this, integrate with the new relic, and try to understand how to monitor it. So again, Adobe is a example. It has adapted AEM setup, elastic load balancing, configured to balance traffic to the dispatches by default. A load balancer distributes incoming requests evenly. We just discussed. To ensure that a load balancer distributes incoming requests evenly across all backend instances, regardless of the availability zone that they're in, enable cross zone. So short and sweet, if we are working in a scenario where where we can enable the cross zone, it is better to prefer that. But I think in my example, I'll be showing the what is referred as the classic load balancing, guys. Okay. So Rahul, can you bring up your screen, buddy? If you're logged into New Relic, if you're not logged in, please also log into that. New Relic and also AWS.
Okay, I will log in.
Yeah. Just give me one moment. Okay. And let's see. We need to go into the load balancing in the
Yes.
console. Let's see, let's just type in load balancer.
Yeah.
Yeah, go ahead, create a new load balancer. You can select, let's see what we have here. Application, scroll down, please. They have given the application, they have given the network. Oh,
Here is the class.
yeah, please select the classic load balancer. You can just give any random name, maybe something like LB1. I think you can leave the default VPC. And let's see, check on the enable advanced VPC configuration. And let's see the port 80. Okay, looks good. And in the available subnets, selected subnets, maybe US East will be okay. A couple of them should be enough. And
Should I add more?
next. I think that should be good. If needed, we'll come back and add them here. And I think you can select the default one here. Yes, the default is already selected. So go ahead and click on the next. Can you go back to the previous place? Just for sake of discipline, can you create a new security group? Yeah, that should be good. And custom TCP, change that to HTTP. Next. Next. In the ping path, you can remove, you can just keep the root, remove the index.html. Click on next. All of them are stopped, right?
Yes.
I think you can turn on any one of the medium, the medium ones.
So do we need this RDS instance which we have created last time?
That should be good. All you need to know is how you configure it, and I think that's what we are seeing. We don't need to go more deeper than that.
So should I delete it?
Yeah, you can delete them.
Yeah. Which one should I start?
The medium, please. I think
Medium one.
just to kind of. That's not the one we just deleted, did we? Go back to the previous screen. Create load balancer screen.
Oh, one.
Refresh, I think.
Oh. Need to again do that.
Oh, okay.
This initializing.
I'm surprised it lost its values.
Yeah. Create LV inside my repository. Enable advanced CP6 configuration. Maximally alphanumeric character. Okay.
You can create a new group. Choose it as HTTP instead of custom TCP.
Yeah.
Just keep the slash. Yeah. Enable cross zone, enable connection. Yeah, that looks good. I think you can add a couple of tags there. Just add any tags.
So this is in different availability zone. We have selected the zone is different.
Pardon me, what is that?
The zone is different. Here it is US is selected 1A and 1B.
Oh, okay.
Maybe we need to select
Let's see.
1C.
Yeah, good one. Otherwise, that would have been a big deal. Thank you, Rahul. Good job there.
Very cheap.
Looks good. Yeah. Next, go to tags. Just add a couple of them just for the.
Yes, Rahul.
You
Hello.
can
Hello, yes, Rahul.
Pardon me?
Sumit.
Yeah, Rahul, can you hear me?
Yes,
Yeah.
yes, you are audible.
Hi, Naveen. Sumit here.
Hey, Sumit.
Yeah. Actually, basic monitoring we have done on Elasticstack and the other tools as well.
Okay.
So same we're doing in New Relic as well, right? But what we are looking for right now in New Relic is to utilize the complete AOps capability So do advanced log monitoring, also anomaly detection, and also a complete infrastructure monitoring kind of a thing. So
Yeah.
we want to utilize the complete capability of the New Relic, and doesn't want, we don't want to restrict ourselves to the basic tasks of New Relic.
Mhm.
So hopefully, if we can speed up the things, and we can cover that part mostly, so that will be really better. That's what we were wanted to convey to you. Yeah.
Sounds good, Sumit. After this, I'm going to be covering the Dev security ops, and after that, I'll return to the AI ops.
Yeah.
Looking
Because these most of the things we have done with a couple of applications
Yeah.
already,
Yeah.
so we can speed up this task, and we can jump onto the those things. Okay.
Sounds good.
Thank you.
Okay. I think you can go ahead and say review and create. Create. Looks good. Instances, and I think now we'll go back to the New Relic. Click on infrastructure and then click on AWS. Let's see. We need to select this one. Where is that? I think it's managed services. Click on managed services in the middle. Below. Yeah. By the navigate to view the blue one. Yeah. And in here, check the load balancer, something like ELB, I think it is. Should see, ELB classic. Yeah. Save changes. Yeah. So ideally, click on dashboard. Ideally, what will happen is the load balancer is hooked up to some nodes and things. And whenever the node balancer gets any of the requests and things like that, in the nodes or the targets that it has, maybe something like a web application or engines, or maybe an Apache server would be running. So all the requests which are being routed, that information is what would be available here. Right now, we just hooked up an empty EC2 instance, but that does not have any target nodes and things like that. But ideally, all the requests, all the other the related metrics would be logged in here. As simple as that. Catching it, Rahul?
Yes.
Okay, that's all I have about the load balancer. And let's see, I'll move on to a little bit of DevSecOps. Come back here. You can
So
stop.
let's stop. Yeah.
Okay. Okay, DevSecOps stands for Dev Security Ops. Traditionally, the development and the operations together was referred as DevOps. And the way it used to work is first the development used to happen, followed by the operations. Then the security aspects of it were getting added to the applications. But in Dev Security Ops, the security, which was generally added at a later point of time, would be integrated right in the beginning of the development. Or in other words, the security aspects of the application would be considered and integrated right at the time of the development. So since the security is being moved to the left, it is traditionally referred as a shift left approach. So in development, we implement security at the very early stage of SDLC during design. and implementation phase. So at the time of design and implementation only we are looking at the development. Security activity is now at the core of application development, and this activity starts from code implementation itself. So again, it's the same thing, just stated in another way. We start the security. We start looking at the security at a development stage itself. We integrate security in operations, operations activity, compliance scans after deployment, and so on. So that is what we'll try to look and understand. Not only do we start at an early stage of development, but also in operations also we will look at in a early stage, and what that means is what we'll try to understand. A few terms that we need to be familiar in DevSecOps is SAST, Static Application Security Testing. It is white box testing that analyzes source code for identifying security issues. So in other words, white box means something you can see. A black box means something you cannot see. White box means you know what you see. Black box means you do not know what you see. So looking for some known security issues, maybe a simple authentication check, maybe a simple authorization check, verifying it if it is, if the authentication and the authorization is working the way it is supposed to work, is referred as a white box testing. Then comes the software composition analysis, scans your code base to provide visibility into open source software components, including license compliance and security vulnerabilities. So in other words, in our applications, if at all we're using any of this open source software, then looking into the license issues of it and any known security related issues is software composition analysis. Dynamic application security testing is a type of black box security testing in which dynamic tests are performed on the application. Black box means, as I said, you don't know what is what is in the test. In other words, you take an application and try to perform a performance test where you're simulating maybe 10,000 users or maybe 100,000 users on a server and see if the application is able to handle it. Now, what do we do? We generally download an additional software which does the performance testing, maybe load runner, test runner, something like that. And we don't know what they are doing as part of their performance testing, but they give us the results and says, hey, this application can handle 10,000 or 100,000 or not. So what did they do? That we don't know. What is that? That is black box security testing. Then interactive application security, it combines elements of both. So together, both the static and the dynamic application security testing is referred as interactive. It scans specific workflows of the code that is very specific to the domain. Hard to give an example. Infrastructure as code, we already know, is the process of creating infrastructure using code definition files and testing these files for identifying issues such as IAC security testing. So we can take our the code configuration files and also write some test cases on it. That is referred as the IAC security testing. Then API security is also called security for microservices. Microservice is a subset of an API. So an API can contain multiple microservices. For example, e-commerce application will have user registration API, and this API will have microservices to create, update, delete, and select and other operations. So in other words, an API can be thought of as a group of microservices is something to be kept in mind. So we'll try to look at an example of how AWS provides the dev security ops. We can take the code from GitHub or the AWS commit, and we can send it to code build, and then we can run pipeline where we can perform some security aspects of the testing guys. Okay. As part of this, we can also use the Sonar Cloud. Sonar Cloud is nothing but Sonar Cube we have earlier deployed on a single server. Instead of deploying the Sonar Cube on a specific server, we could use the Sonar Cloud, which is nothing but the Sonar Cube on their cloud. So instead of giving the IP address of our server, we give the IP address of the URL, private IP of the Sonar Cloud, and everything remains the same. We get the similar analysis and the results of that. So again, Sonar Cloud is a software as a service platform that helps to keep our source code free. So we try to identify the code quality and the code security issues. We can define quality gates within Sonar Cloud as per project quality standards. We'll try to understand what is a quality gate. And a few of the tools generally talked about when talking about the DevSecOps is Snake. It sounds it sounds like Sync, but it's Snake. It is an organization that develops security tools, SaaS, source code, open source, containers, infrastructure as code. Or in other words, it's a tool which is capable of identifying any security issues in source code. It identifies any open source libraries, any license issues, and it will automatically identify any security issues in the containers and also in the infrastructure as code. So it's a separate organization where they are explicitly providing the tools for performing all these things. Okay. Another thing to be familiar is OWASP. ZAP is an open source web application security scanner. It is intended to be used by both those new to application security as well as the professional penetration testers. It is one of the most active open web application security project and has been given flagship status. It can scan both web applications and API. So again, it is also used for looking into the security aspects and things like that. And if time permits, we'll have a quick look at that, guys. Okay. So Rahul will run a quick test. We'll run a quick project on AWS. If you can go back to this AWS.
Yeah.
Okay, let's in the console type in code commit. Let's create a repository. Code commit, yeah. Create a repository. Looks like I already created that. Okay. Let's call it, let's just give it security report 2 or something like that. Scroll down and click on create. Don't need code guru. That is if you're really a developer, if you need very low level details. In clone URL, if you click on clone URL, you can copy the clone HTTPS and copy it. Okay, I think we will need that one. Then let's say back to, let's say go to IAM. We need to add a user. Click on.
We already have one user for this.
Okay. We can.
User, the Naveen user which we are using.
Okay.
We already have.
We will also need to add.
Yeah, we have created that XCC secret report code commit.
Okay. We need to add the AWS code commit access in row. So scroll please. Permission.
It has a permission of administrator.
Code pipeline, right? I think you need to add AWS code commit full access.
Okay.
And wait, we attach existing policies directly. And here you type in AWS code commit full access. Code commit full access.
Yeah.
Okay, and you have the credentials. Say go to security credentials. You need to regenerate or download them. We'll need any one of them. We need to connect to this. So you may need to.
Yeah, I have that credential. Yeah, which we have used during last time the code commit.
Open for a moment. And next, come back to, let's say, the scroll up, please. Permissions. Click on permissions. Scroll down. Scroll down. Permissions.
Let me.
Go back to security credentials. Scroll down. Look for Git credentials. Yeah. So, okay, you're already looking at the Git credentials. So from code commit, we should be able to use this credentials, right?
Yes.
Okay. Okay, now let's get back to Git bash. And let's say create a directory. What is this one? This is DevSecOps, right? Let's say I call this DevSecurity, maybe DevSecOps. Okay. And go into the directory. I think you've already copied the git clone, right? So just type in git clone space and paste that git clone that you copied, yeah, and press enter. May I ask you for the credentials now? You have to have, okay, so it's not asking, you already configured. Okay, that's a good sign. It's not asking, so which means we already accepted it. And
It is saying that you have untick repository.
yeah, because our repository is empty, you cloned it. The thing is, it cloned it, so in other words, it's connected. Okay, sorry about that, Radha. I had a power cut here. Sorry about that. Unfortunately, it's starting after 3 p.m. for us, and non-stop twice. So sorry about that. Let's see. So we have Chrome. Can you type in Git status? Git status.
Yeah.
Not a Git repository for any of the parent directives. Can you open up, just type in ls-a? Security report 2. Can you go into the directory security report 2? ls-a. That's great. Do a git status. Okay, so we have not added anything. So if you access our G drive, the one you should find something called a Java reachability zone. There should be a file called Java reachability zip file.
No, sir.
Scroll, please.
It is not here, sir.
Oh, one moment. One moment, please. I'm uploading it. Downloads. Let's go to downloads. Okay. I just uploaded the file. Can you refresh, please? Can you refresh one more time? So there you go. Java reachability playground.zip in the middle. And download this one into, first download it, then unzip it.
Where should I unzip it?
You can unzip it to the directory and we'll cut the files manually.
To the directory which we have created now.
Yeah. Yeah,
inside this directory.
answer there. No. Okay. Let's say go into the open up Windows Explorer and go to this directory. We'll manually cut the files. Go into the directory. Go into the directory. I think you can cut all these files from here, put it one level higher.